Welcome to This Explainer. Today, we are stepping into the ring for what I like to call the boxing match of your academic year, the Cambridge Physics 625 exam. We're totally rethinking how you tackle mass and density fundamentals. Look, if you've ever sat in an exam hall feeling completely overwhelmed by endless formulas, or if you've struggled to decode those really tricky command words, you are exactly in the right place. Imagine two students taking this paper. Let's call them Alex and Sam. Alex is the heavy hitter who overloads every answer with raw, memorized physics facts, throwing everything at the page but offering zero real analysis. Sam, on the other hand, rushes the delivery. Sam glances at the command words, totally misses the actual requirements, and throws a wild punch that completely misses the mark. Both of them walk away losing points they absolutely should have won. Why? Because they're relying on rote memorization instead of strategy. We are moving far away from that today. We are focusing entirely on a concept-first framework. You need to float like a concept and sting like solid evidence. By the end of this session, you're going to see how shifting your mindset from just memorizing definitions to actually grasping cause and effect will completely transform your approach, turning those red pen marks into green check marks. Let's get right into it.
Right off the bat, we need to completely change how you start an answer. Instead of kitching things off with a totally boring textbook definition, like Alex, who just robotically writes density is mass per unit volume, I want you to stop. Look at the question and ask yourself a starter question that makes the physics feel intensely real. Ask yourself, what physical effect, what actual measurement, or what real-world prediction truly depends on this understanding of mass and density? Picture a massive hot air balloon majestically rising against the pull of gravity. Or think about a colossal, heavy steel boat effortlessly floating on the ocean, while the tiny, lightweight rock sinks straight to the muddy bottom. Why does this actually matter for your exam? Because when you approach learning through the lens of these tangible, real-world effects, you stop relying on a rigid mental script. You become significantly better equipped to reason your way through those completely unfamiliar curveball exam scenarios. The examiner doesn't just want the formula. They want to see that you can connect the theoretical math to actual physical events taking place right in front of you. So how do we make those connections under exam pressure? We use a specific, unbreakable strategy. Think of it as your ultimate physics success blueprint. It's a 4-step framework that structures your reasoning, and it perfectly parallels the classic point, evidence, explanation, and link method that top students use. Step 1. Identify the specific quantity or phenomenon you are dealing with. Just point it out clearly. Step 2. Explicitly state the mathematical or physical relationship involved. That's your evidence. Step 3. Explain the underlying physics of exactly why that relationship exists. And finally, step 4. Link it back. Connect it to a real observation, a practical experiment, or an actual device. For example, use this framework to explain how a submarine strategically controls its internal buoyancy by taking in water to dive and expelling it to surface, or how the liquid inside a thermometer expands so predictably with heat. That sequence, identify, relate, explain, connect, is your guaranteed combination for max marks. The absolute best exam answers don't just parrot facts. They demonstrate a fluid, step-by-step combination of deep conceptual understanding and practical application. Now, before we continue and look at how to actually write these out, subscribe to our YouTube channel AC Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's look at how this conceptual understanding actually builds, because this is where a lot of students, just like our hypothetical student Sam, trip up. It is a super common mistake to jump straight into heavy math or dense technical jargon because you're rushing to sound smart. But the most effective learning path and the safest way to secure your marks actually moves from the concrete to the abstract. You should always begin with a tangible, everyday example. I want you to visualize a solid block of wood. Think about its actual heft. Imagine how it feels in your hand, its mass, and imagine exactly how it behaves if you drop it into a bucket of water. It bobs back up, right? Only when the physical reality of that wooden block makes total intuitive sense to you should you transition to discussing the atomic level spacing or introduce the formal symbolic physics formulas. Once that formal high-level definition is locked in, you return to a worked explanation to test your understanding. This deliberate, gradual transition from everyday language to precise physics vocabulary ensures that the words you are writing on that exam paper actually mean something real to you. They aren't just empty symbols. They are a true reflection of the physical world. This idea perfectly translates into the interactive workshop portion of our strategy, especially when we start looking at complex data and graphs. Interpreting graphs is a massive part of the 0625 syllabus, but I need you to realize that they aren't just geometry exercises. You must connect visual elements directly to their physical meanings. When you are staring at a graph under a 60-second time crunch, what does the slope physically tell you? Is it representing the literal acceleration of a ball rolling down a ramp as it picks up speed? What physical quantity does the area under that curve represent? Could it be the total energy stored in a tightly compressed spring just waiting to be released? What does a sudden change in direction, or the overall curvature and shape of the line, mean for the physical objects we are analyzing? By directly linking these abstract mathematical visuals to highly tangible real-world physical effects, you completely elevate your understanding. You stop simply reading arbitrary numbers off a grid, and you start actually decoding the core mechanics of the physical universe. This is exactly what separates the top-tier grades from the rest. And that brings us to the absolute golden rule for tackling not just mass and density, but fields, forces, or particles. Here it is. You must insist on cause and effect rather than isolated facts. Whether you are dealing with density fundamentals, electrical circuits, or wave mechanics, this principle is the core of your physics mastery. Memorizing a list of isolated facts is an incredibly fragile strategy. It shatters into pieces the very second an examiner phrases a scenario in a totally new or unexpected way. But if you demand to understand the cause and effect, exactly why a change in volume leads to a specific effect in density, or exactly why a specific applied force causes a distinct physical acceleration, you are building a robust, unbreakable conceptual chain. This precise cause and effect reasoning is the exact target examiners are hunting for when they assess your paper. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's put this into practice and find the flaw. We can clearly contrast the safest, most bulletproof method for structuring your exam answers against the most common exam traps that lose students' marks. It's like comparing a thick, interconnected steel chain to a completely broken one. On the strong side, we have our safe method, the one we talked about earlier. You start with a clear definition, you state the relationship, you provide the physical explanation, and you finish strong with a real-world application. That framework completely secures your foundation. On the broken side, we see the absolute most common weaknesses. For instance, Alex writing down a perfectly correct, mathematically sound formula, but completely failing to explain what any of the variables actually stand for. 0 marks for explanation. Another massive trap is quoting a physical process without actually linking it back to a physical effect, or giving a cool real-life example without showing the examiner exactly why it follows from the underlying physics principles. Keeping your answers tightly bound to structured reasoning directly counters these exact errors and guarantees you pull every single possible mark out of the question. To make sure your conceptual chain stays entirely intact under the pressure of the ticking clock, I want you to use these 4 quick recall prompts. Think of this as your speed writing cheat sheet. Whenever you are reviewing the fundamentals of mass and density, or frankly any physics microtopic, close the textbook and fire these 4 questions at yourself. Number 1. What is the core idea? Define it as simply as possible. Number 2. What actually changes physically in this specific scenario? Number 3. What exact physical quantity or what specific type of graph would show this change clearly to an examiner? And number 4. Where is this concept actually used in the real practical world? Don't just mumble these in your head. Actually speak the answers aloud. Speaking them forces your brain to process the information differently and proves whether you have truly internalized the physics. If you can confidently navigate through these 4 prompts in under 30 seconds, your foundation is absolutely secure enough for the toughest structured questions Cambridge can throw at you. We're going to wrap things up with one final crucial question to remind us that mass and density are not just hurdles to jump over for an exam. These are the fundamental concepts driving actual cutting-edge engineering and scientific discovery. The ideas we've talked about today don't just live inside a syllabus. They are the absolute bedrock of real-world applications. They dictate how we design safer, more efficient transport. They are essential for engineering next-generation energy systems, advancing global communications, and even developing life-saving medical technology. Whenever you learn a physics concept, you should always be able to name at least one real-world situation where it actually matters, and explain how that physics helps us predict or improve an outcome. So look around you right now. How is the physics of mass and density quietly operating the technology in your room? Keep questioning it. Keep using the framework. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @AceTheExamsIGCS to excel in your Cambridge examinations. Subscribe right now to @AceTheExamsIGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing.
Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here.